Hello, welcome to IBCC channel. In this video, we are talking about the OSPF domain structure. So issue with a large OSPF domain. When the OSPF domain gets very large, there has a lot of issues. So when a large number of routes run OSPF, the link state database becomes very large and requires a large amount of the storage space. A large link state database also complicates the short path first computation and overload the routers. As the network grows, the network topology changes, which results in routes flopping and frequent OSPF packet transmission. When a large number of OSPF packets are transmitted, the bandwidth usage efficiency decreases. Also, each router on network has to recalculate the routes in case of only topology changes. So how to fix these issues? Areas are designed to resolve this issue. What is area? OSPF domain can be divided into subdomain called area. Areas are identified by area ID. The OSPF link in the same OSPF area have the same area ID. Area ID is expressed in the IP address format or decimal format. For example, area 0.0.0 is equal to the area 0. Router within the area must maintain a topology database for the area to which it belongs. The router does not have detailed information about the network topology outside its area, which thereby reduces the size of the database. All routers within areas have the exact link state database. A network segment or a link can belong only to one area. Take a look at this diagram below. So this OSPF domain is divided by two areas. One called the area 0, another called area 5. See, since the area ID can be expressed by decimal mode or the IP address format, so you can see the area 5 can expressed by 5 or by 0.0.0.5. So every router every OSPF enabled router in the OSPF domain have a link state database. So the link state database contains the area information. So a router in one area, he don't know the other areas, the network topology. For example, router R1 in area 0. R1 do not know R5. R5 is in the area 5. R1 do not know how R5 connects. So R1 do not know R5 connect to the R2 and connect to the R4. They don't have this detailed information. Same thing is true for the R5. R5 also do not know only detailed information in the area 1. He don't know, for example, he don't know how R3 connected. So, all routers within the area have exact link states database. So you use this diagram as examples. So R1 and R3 within the area 0. So R1 and R3 have exactly link state database. So R2 and R4 is special. R1, R2 belong to area 1, is also belong to area 5. So R2 contains the information. So R2, the link state database, contains the information about the area 1, also contains the information about area 5. Same thing true for the R4. So take a look at this link between the R2 to R4. There's one link. between the R2 and R4. This link only can belong to one area. They can either belong to area 0 or belong to area 5. They cannot belong to both areas. In this diagram, this link here belong to area 0. Functions of the areas. OSPF flags link states advertisement to exchange the link states update between routers. Only changes in routing information is flagged to all routers in the network. The area is introduced to put a boundary on the explosion of the link states update. Flooding and the calculate of the SSP algorithm on the router is limited within an area. Area limited scope the routing information distribute. It is not possible to do the router update filtering within an area since the link states database of the router for same area must be synchronized and must be exactly same. However, router summarization and filtering are possible between different areas. So take a look at the diagram below, right? So R1 belong to area 0. So R1, since he run the OSPF, he will flood the LSA out to all his interface, OSPF enable interface. So when this LSA propagate to the R2, R2 receive it. Then R2 not get flood this LSA into the area 5. So this LSA come from the R1 is flood to R2, then stopped here, and now flood over to the area 5. So that means boundary router put the area put the boundary for the LSA flood. So since you see R1, also take a look at the area 0. You see the R1 and R2 belong to the same area. So if you want to filter the routes between the R1 and R2, filter the OSPF routes, that is not possible because the database on the R1 and the database on the R2 regarding the area 0 must be synchronized. So if you put the filter in between these two routers, the LSA database cannot be synchronized. So the filters not allowed within the areas. However, if you want to do the route summary between the area 0 to area 5, so that is possible. So next, we are talking about the area types. OSPF area can be categorized to the OSPF backbone area and non-backbone area. So what is that backbone area? That's simple. Area 0 is defined to be a backbone area. Backbone area have some requirement. The first requirement, if there are multiple areas in the network, one of area must be backbone area. The backbone area connects the rest of the area in the network. The backbone area must be contiguous area. If backbone area is partitioned, part of the OSPF domain will be unreachable. So this needs a virtual link to be configured to repair these partitions. And just take a look at the right-hand side. So if the area connect like this way, so it's area 0 connects to the area X is not 0, then connects to area 0 again. This kind of connection is not correct. So traffic cannot send from the left side area 0 to the right side area 0. So what is a non-backbone area? Non-backbone area is an area ID other than 0. So non-backbone area can be categorized as below 4 different types of area. Standard area, stop area, total stop area, not so stopping area. We will talk about those type in next video in detail. OSPF router type. First, the OSPF router type is called ABR. ABR means area border router. OSPF requires a backbone area must be exist if there are multiple areas to form OSPF domain. So the router between the backbone area and the non-backbone area is ABR. And ABR is considered a member of all area is connected to. ABR must therefore maintain the information describing the backbone area and other attached area. So you can take a look at the diagram, the two diagrams below. Left-hand side, I call this the correct setup. Right? So in left-hand side, there is a backbone area. So area 0. There is a non-backbone area 5. Also we call the standard area 5. So between the backbone area and the non-backbone area, there are two routers. Those two routers are ABR routers, area border router. So you take a look at the right-hand side. So I call this the incorrect setup. So in the right-hand side, there's two areas connect together. However, there is no backbone area. So one in the left-hand areas we call the area 11. Right-hand side areas called area 5. So although this is two different areas, the router between these two different areas are not ABR. The reason is there's no area 0 exist. ABR must be one side connect to the area 0. So keep this in mind, it's important. So another OSPF router type is called ASBR. Stands for the Autonomous System Boundary Router. An autonomous system boundary router is a router which connects the non-OSPF network to the OSPF network. Non-OSPF network is an external destination from OSPF points of view. An autonomous system boundary router advertises external destination into the OSPF domain. So you can take a look at the diagram below shows. And the right-hand and the left-hand side, here is routers R3. It is ASBR. The reason is R3 connect to a Juniper router in the left. Between the R3 and the GR01 router, they run the EIGRP protocol here. So it's not OSPF protocol. So since R3 is connected to the external protocols, so R3 is ASBR. So if the network from OSPF, for example, from the area 0, some routers want to communicate with the GR01 routers. So that GR01 contains the routing information has to be redistributed into the OSPF or by the ASBR router. So this is a purpose of the ASBR. In the right-hand side, there's another ASBR. Since this ASBR is connect to the static routes to an outside router other than OSPF. Next, we are talking about the OSPF domain structure. OSPF domain consists the OSPF area, all areas. That's what that means. That means OSPF domain can contain only have one area, or can contain multiple areas. If there is more than one area in OSPF domain, one of the area must be the backbone area. Other areas connect by backbone area, area 0. It is OSPF hierarchical structures. Two non-backbone areas can't communicate with each other if there's no backbone areas interconnect between them. The ABR joins backbone area and non-backbone areas. The ASBR between the OSPF domain and non-OSPF domain. Below the diagram explains this. So below the diagram, this OSPF domain contains multiple areas. So if they contain the multiple areas, the area 0 must be exist here, so area 0 exists. So area 0s connects all the other areas. Area 0 connects area 5, area 7, and area 23 in this diagram. So if this router R8 in the area 5 need to communicate with the router 6 in the area 23, they must go through the area 0. So even these situations, area 5 and area 7 is connected just directly on the same router R1. So if R8 want to send the routing informations, OSPF routing informations to the R11, this information must go to the area, must go to R3, then go to the area 0, then back to the area 7. So if the R3 don't have area 0, then even these two areas directly connect, they cannot communicate. So that means area, non-backbone area must be connected to the backbone area to communicate each other. So ABR here is joined backbone area and non-backbone area. So the ASBR here is joined the non-OSPF domain and OSPF domain. This is OSPF hierarchical structures. Now we talk about the rule of the divide OSPF domain into different areas. To divide the OSPF network into the multiple areas, there are rules to be followed. The first rule is a backbone area, which connect a set the independent area into the single area. That the backbone area must be exist. Each non-backbone area must be directly connected to the backbone area. This connection can be a simple logical connection through the virtual link. We'll talk about this in the coming videos. The backbone area must not be partitioned. In other words, divided into the small piece under only failure conditions, such as a link or router down events. So below the diagram in the left-hand side show the wrong connections. This diagram, the two backbone areas connect by the non-backbone areas. This is not correct. So backbone area cannot be partitioned. Yeah, cannot be partitioned. That means these situations. Or if some links down cause the backbone area become several pieces, that's also big failures. So in the right hand side, yeah, we explained this one in the previous videos. That's an incorrect setup because it's because it's multiple areas. However, missing the backbone area. So this is an incorrect setup. So here is a couple examples of the OSPF domain examples. So the first in the left-hand up corner, in this domain, or OSPF domain, only have one areas. So we set up this area as area 0. This is a perfect fine. In the right-hand side, there are single, there OSPF domain. There is a single areas. These areas can be only area numbers. That's also good. That's correct. That means works. So that's the third diagram here. So that's also good. That's also good. The configurations. See, so there's the three areas. Area 0 connects to two areas. Even these two non-backbone areas have the same area numbers. That looks odd, but that works. Yeah, that's correct. Let's take a look at the first one. First one is very normal setup. So we have a backbone area, also have a non-backbone area. Connection like this way. So the non-backbone area X, connect like the redundancy path like this way. So this setup also good. There's no issues. Okay, so I think we can end this video for now. Hopefully you enjoyed